I'm going to write it down. Find the sum of an AP, and then they're saying, no, arithmetic series. So that means you are adding the terms of the roller. Okay, and these have a common difference. And they are saying also, so we know the number of terms, it's 20. What else? And they say if the first term is 50 and the last term
is 10, we can use that formula.
is what? 10. So last term.
We can use that formula.
Yeah. What seems to be the problem here? So you have got the formula here.
So
the L refers to T sub n, which is our last term.
Yeah.
And the first term is 50. And we know the number of terms. Why did you bring this question? Anyway, so the sum of the 20 terms becomes then half of 20 and 50 plus 50 plus 10.
Yeah, 60.
Right, so that's 10.
60, 10.
So the sum of the 20 terms is 600.
So good question.
Yeah, it's a straightforward question. Why don't we bring such a straightforward question? Anyway, what would have been the issue if, suppose, you wanted to use the formula what should have been the issue? Is that information enough for us to use that? We know the first term, we know the number of terms, but we don't know the difference. And the story does not even say anything about it. Okay? So because that is missing, it will probably be best if you only use the information that we have. But, yeah, this is a very straightforward question.
Sir.
I'm listening. Question 6 maybe?
Maybe, yes. You can do 7.
Okay, maybe question 4. Yeah?
Yeah.
The question says,
The
the third term of an arithmetic series.
Yes.
When you think about that, then you have to think about this formula. Yeah?
The key they see
is 11, and the sum. So when you're told the third term, then you know what the third term is, right? Probably can find it if you want to. You'll come and see if that information is important. And then they say the sum. Where are we now? Of the first 6 terms, eh? Okay. So when you do the sum of the first 6 terms, all right, we know the third term. We don't know the first term yet. Find the first term and the common difference. So I'm just going to write
A and B.
Find A
And B.
and D. The moment you're supposed to find 2 variables, you use what? Simultaneous equations. So you have to solve them simultaneously. Understand that?
Yes.
At the same time. So we have to create 2 equations. The first equation we're going to create is the third term. Now the third term is going to be A plus 3 minus 1D, which should equal to the value that we are given. So it should be A plus 2D is equal to what? So let that be our first equation. Then we're also told that the sum of the first 6 terms, therefore we're going to use this formula here. So the sum of the first 6 terms we just substitute. We don't know the value of A, but we know that it's 6 minus 1. We know the value of D. No, we don't. But we know that the sum is equal to what? 16. So we clean this up. So this is half of 6, which is 3. Then you have 2A plus 5D equals to 60. Maybe you can go ahead and divide throughout by 3. Okay, or you can distribute that 3 if you want to. But I think it's best if you do that. So you're going to have 2A plus 5D equals to 3 goes in there. And this could be your second equation. So from here, you just solve them simultaneously. Maybe we can make A the subject of the formula. Can I use that method?
Yes, definitely.
Remember, you can do anything, right? And we're going to substitute into, we're going to substitute this value into B. So into B, everywhere we have an A, it's going to be substituted by that. So 5D equals to 20. So maybe I play around with the colors here. So I have 11 minus 2. You can go ahead and use any other method. Do you guys still remember how to solve this using matrices? It's gone, is it? 22 minus 4D plus 5D equals to 20. 5D minus 4D just gives us D. 20 minus 22, so D therefore is minus 2. You agree?
Yes.
5D minus 4D is 1D, 22 subtract from 20. Okay. Now, so again, we sub D equals negative 2. Well, doesn't matter in which one I substitute. I'm looking for the value of A. So I can substitute it, maybe I call it my C. So that's going to give me A equals 11 minus 2 by D. And the answer is A equals to 11 plus 4. Happy? Therefore, the first term please remember, you are answering on the lines there, and you need to justify your answer. Okay. First term is 15, and the common difference is minus 2. Does it make sense? You see question 5 there, what people are doing. Question 5 says, what is the sum of the second 10 terms of the arithmetic series 4 plus 7 plus 10? What does it mean? If I was to ask you the first 10 terms, you will know how to try. So the second 10 terms will be what?
20.
The sum of the 20 minus the sum of the first 10. Is everybody clear with that? You're going to write it down. I think you are that side now. I can take over this. It's a very short question.
Yeah.
Okay. What is the sum of the second 10 terms of n? So the moment we talk about series, we're adding the terms. 4 plus 7 plus 10. Alright? So, important thing, we find the sum of the first 20 terms. Then we minus with the sum of the first 10 terms. This is going to give us our required. Does that make sense? So you first find the sum of the first 20 terms. Because you need to identify first what is your A, what is your D. And that A can only be one A. You follow? Can only be one first term, which in this case is what?
4.
4. And so let us see. What is our A equal to and what is our D equal to? So A equals to nothing but 4. D equals to nothing but 7 minus 4, which is 3. So now you have your A, now you have your D. Okay, so we're just going to punch it in. By the way, which formula we're going to use? The long one or the short one?
The long one.
We don't know the last term of each. So we're going to say the sum of the first 20 terms is 20 over 2. 2 times A plus 20 minus 1. And the common difference being what? Right, the A is 4. We are going to subtract this. Okay? So just punch it in as it is there. We're going to subtract it with the sum of the first 10 terms, and that is going to be 2 times 4 plus 10 minus 1,
9.
and our D is what?
3.
3. Okay, so what is our final answer? Just punch it in like that on your calculator. We can go ahead step by step, but I just want the final answer. 475. So the sum of the second 10 terms. Does that make sense to anybody?
Makes sense.
Can I just I'm just going to write it in long form, just so you get an idea what I mean by this, okay? So the first term is 4 plus 7. So we're adding 3 every time.
10.
Okay? So plus 10. What is next?
13.
Next?
16.
Next?
19.
Some people don't know we're adding 8 again.
Yeah.
So 19 plus 3 is 21. My goodness gracious. Plus another 3. Plus another 3. Plus another 3. Say what? Okay, so how many terms do I have now? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the first 10 terms. But we're not looking for the sum of these. But we have calculated the sum of these
Which is
from here. You follow? We are interested in the sum of the next. So the next one. So I'm just going to continue, right? So let's add then 3 again. 3. Oh my goodness. No, I'll wait. Add 3 again. Add 3 again. Say what? Add 3 again. And so on. And so on. Now here comes the tricky part. Because someone did not know it says 51. Add 3 again. Say what? How many are these terms now? 1, 2, 3, 4, 5, 6, 7, 8. So 2 more. And then? Say what? Good. These ones in blue. These ones in blue. This ones. If you add them, they are giving us this 500, the 475 that we have here. But we can't start calculating from 34 to 61 because we don't know the last term number one. We also don't know where the 10th term or 11th term is starting. Okay? Is it possible for us to find the 11th term?
Yeah.
Okay? So, for us to find the 11th term, we will be using the formula 4 plus 10. Now what's our D? That's 30 plus 4. 34. It's 34. Okay? So we know that according to, if we want to use the other formula, if we want to use this formula here, we take the first term and the last term. So now the first term that I'm going to work with should be this 34. But here's the thing. Do I know the last term? The last term is the 20th term. So 20th term again becomes 4 plus 19 times, are you with me? Times 3. Now, don't worry. For those of you who don't know, 19 times 3 is what? 57 plus 4. Say what?
61.
So now, if you use this formula, so you want to find the last 10 terms, and I know that the ones in blue, they are 10, right? So I'm just going to have 10 over 2, and my first term becomes what? 34. My last term becomes what? Now, if you work this out, what do you think you will get?
170.
You're just guessing, or you know this for sure?
No, sir, you see the.
But you see, this is too much work, people.
Too much.
You follow what I mean? That's why we first find the sum of all 20,
Subtract.
and then we subtract the sum of the first 10. Do you get that? And that answer gives us the sum of the last 10. So this concept is quite important. Well, either if you do that, you go a long way, it's not a problem. Because now you know the second 10 term, so it must start at 11 and obviously end at the 20th. So what is the 11th term going to be, which will be now my first term in this particular case, because I'm working from the 11th term. What is the last term equal to? Okay, punch that in quickly, and then you can use that formula. So either way, it's totally up to you. But this reasoning is important. When you find the sum of all 20, subtract from sum of the first 10, that will be the last 10. That makes sense? Ready to go? So question 6 is similar, nothing to be afraid.
7.
Question 7. The first term of an arithmetic series is 2. Sum of the first 8 terms is 15. And the sum of the whole series. We don't know what is the number of terms, but we know the first term. We know the sum of the first 8.
You can find the sum of the 8 terms.
So this is the last one on this, based on this stuff, before we go to the sum of the geometric series. Is that right?
No.
So it says
Sum of the 8 terms.
the first term of an. So remember, the moment we talk about series, the terms are being added together. So we have to use somewhere the sum. Yeah?
Yes.
Of the number of terms. And so on and so on. That's 2. That means A equals to 2. Does that make sense?
Yes.
The next one says the sum of the first 8 terms is 58. Okay? So that's the sum of the first 8 terms is equal to what? 58. So we can use, if you use the formula here,
And the sum of the whole.
well, this one you know the first term. Alright? The only problem is we don't know the difference. But let me suppose before I continue,
We need to find the difference.
let me before I continue, let's take the sum of the first 8 terms. That's 8 over 2. Okay? 2 times being that 2 here, plus 8 minus 1,
Which is
D should give me 58. If I use this formula, I'm going to calculate the value of D, which is what the question demands. But there's still something else the question is saying. Right, so let's just do this. So this is 4
Yes.
plus 7D. And the here is 4, right? Right. Does 4 go in 58? Yes, as long as the number ends with a multiple of 4 here, you will go in there, right? How many times does 4 go in 58? He was saying yes, it does. You must pay attention. Does 4 go in 58? Without leaving a remainder. So how do you know whether a number is divisible by 4? When the last 2 digits are multiples of 4. Like 12, 4 goes in 12. Right? What about 36? Goes in 9 times. You don't know. Are you counting? Hey, unbelievable. Anyway, so what can you do? You can multiply this over if you want to. Or I can divide it by 2.
Just multiply.
Anyway, so what course multiplying are you talking about?
Multiply only.
So that's 16.
Yes.
4 by that is 28D. And that's 58. So 28D equals to 58 minus 16. And by the way, what is 58 minus 16? So D becomes 42 over 28. 7 goes there 6 times, 7 goes there 4 times. 7 goes there.
Why is it?
Okay.
It's 1.5.
Do you know what did you say?
The answer is 1.5.
No. How many times is 7 going 42? Okay, then how many times is it going here?
4.
Okay, now I'm going to ask you again. How many times does 14 go here? My goodness, you don't know. 3 times, and 14 goes there 2 times. Okay, I mean, you have something of your calculator right there. Now they are saying, there's also another story, right?
Yes.
It says, it was part of this story here, né?
Yeah.
And it was just me now working out the D.
Yeah.
And the sum of the whole series is 325. What is the number of terms of this series? The whole series. If it says the sum of the whole series. The first 8 terms is 50. The whole series is 325. So we need to find out the number of terms. Okay? So how do we find the number of terms? So this is now the important part, right? So we had to find the common difference, which is what we got. So sum of the whole series will be S sub n. We don't know the number of terms of this series. You understand that? But we do know that the first term
is 2.
We do know the first term is what? It's 2. Again, we don't know the number of terms, but we do know that the common difference is half, 3 halves.
Yes.
And we do know that everything here is equal to what?
300.
Okay, so inside you can clean it up, right? So this becomes n over 2. 4, right? What is 3 halves? If you take away 1.5 from 4, what do you get? If you take away 1 from 4, what do you get? And if you take a half from 3, what do you get? Here we are.
I said it.
I want to start again, right? If you take away 1 from 4, what do you get? And if you take a half from 3, 1.5. Unbelievable. Yeah, no, these things, they tend to happen, ladies and gentlemen.
The brain.
The brain. Okay, so this is 2.5 here. You follow? Okay? This is 2.5, yes? Which is the same as 5 over 2. Am I right?
Yes.
This is the same as 1.5, yes? So I'm going to multiply 325 times 2. I'm getting rid of that fraction there. Okay? So what is 325 times 2? What be with me? 650. Does that really take a calculator?
Yes. Why don't you use
Very
it?
good.
Yeah, you guys are very interesting.
Special.
Do you realize that I'm making the denominators the same here?
I see.
Yeah? You do realize that, eh? 5 halves plus 3 halves. So then, that's the same as 5 plus 3 over 2. So I can get rid of these 2 again. Which end are you talking about?
Yeah, outside.
The outside. At least now it's not sleeping. Are you happy now? I can see Anne's face. He goes like, oh, I don't like it. You want me to separate it, Anne? Because what I'm doing is I'm going to multiply like that. So that becomes 5 over 2n
Some quadratic.
plus 3n squared over 2 equals 650. Am I right? N. So n becomes 3n squared plus 5 equals to 650 times 2. You agree?
Yes. 1,000.
Getting rid of that denominator? Is there not something missing?
And nothing.
You are sleeping.
Oh,
Now what is 650 times 2? Please, God, be with me.
1,300.
1,300.
I think.
You think?
yay.
Right.
You agree?
Yeah, bro.
So the quadratic becomes 3n squared.
Completing the square, so just
He says completing the square.
I like it.
Just because you like something does not mean we are going to do it.
So it's the easiest.
When you can go ahead and use the quadratic equation formula from here on, right?
Yeah.
This, by the way, does it factorize?
You don't know. You don't know what to do.
But what is delta equal to?
Discriminate.
Minus
A is 1,
3.
and that is? Please put that in your calculator and tell me what it is again. Don't worry, we will wait. Good.
Which means there's a solution.
3 to the power. Square root of that. What is the square root of 15,625?
Yeah.
Okay, good, 125. So this is 125, yes? You agree?
yes, sir.
Okay, so according to our quadratic equation formula, A equals to 3, B equals to 5, and our C equals to negative 1,300. So N equals to minus B, which is positive 5, plus 125 over 2 times, or N equals negative 5 minus 125.
20.
Can I put it over 6? You get the idea?
20.
This answer here is what?
20.
120 divided by 6.
20. Straightforward. That's also it.
And this answer here is what? Minus 130 divided by 6. In fact,
minus 21. Something.
this is not even going to be considered.
Minus 21. 27.
The position, the number of terms cannot be a negative. You can't have negative. So there are 20 terms in this series. Does that make sense?
There you go.
So what is the last term? How do you find the last term?
20.
So what is the last term?
It's 20.
The 20th.
So how do you find it?
It's
It's
up.
up 20.
Piece of 20. So when the question asks the last term, you have copied this part. Alright, so they are saying that means find the 20th term. So T sub 20 equals to our A, which happened to be 2, am I right? Plus 20 minus 1. What is our D? 3 halves. Am I right?
Yes, sir.
Right. So just punch it in your calculator and tell me what is the last one.
30.4.
Say what?
30.4.
Can someone else give me an answer, please?
30.4.
Someone else give me an answer?
So we need to trust
It's a half. You can see it's half here.
Yes, I'm waiting. What?
20.5.
Okay. They
See
didn't
what
know.
see what they did.
What did they do, by the way? What did they do?
So you're saying 30.
How are we fine so far with this? Okay. So we are going to now do the side. With GP, you must just be a bit careful.
So 30.
You are the idiot who was saying 13. You have a problem with 13. I also don't know why I would say 13. This is already 19 times 1.5. So there's something also wrong with me if I was taking your answer.
13. Oh, easy.
And the thing, the weird part is, Bradley, Mr. Bradley was copying. What do you mean you didn't write this? No, you were facing this side. Are you sure? So what would you have done if you were arrived here? You would just have copied as well, right? Careful, careful. Let's not trust what he says. He's not audible enough. He's keeping on. So as a baby, you cried in vowels. How many vowels are there in the English alphabet? So he was crying. You get it, right?
So we're alive.
We are alive for a reason. Are we done copying? So let's look at the sum of a GP, or geometric series. So the moment we talk about series, because you must know we're talking about a sequence, and you are adding the terms, and you also need to be, in the exams, you must always make sure whether the series is a geometric one or whether it's an arithmetic series. It's not always a good total. So it goes the same, you're supposed to find sum given the last term. If you have given the last term, what did you say? If you given the last term, that becomes T sub n. Which means you can take your formula and then equal to that, no? When we use T sub n, when we are given the last term, is when you want to find exactly how many terms there are. Okay. And then after you decide, then you can use the formula. So I'm just going to do a few random ones, okay? And then the rest you do because I want to get to 600. Is that fine?
Yeah.
Okay, so first things first. Well, I'm going to look at a few there. Alright, so sum of a geometric series. So r to the n minus 1, here becomes r minus 1. Or you can use the other one.
R is greater than.
So I can only here. We tend to use this one when r is what?
Greater.
We also know that r cannot equal to
1.
Otherwise, the denominator becomes 0, divided by 0 is not possible. Okay? So,
Greater.
if r
Greater.
is a number that is greater than 1, then we may use this one. If r is a number less than 1,
Doesn't matter.
doesn't matter anyway. Doesn't matter which one.
Doesn't matter.
What did you say? Yeah, bro.
Doesn't matter.
After we this thing will get into your head.
Yeah.
It doesn't matter which one you're using. But you should just know that, you know, when you are looking for the n, and the formula involves something like this, you're not given like a formula, this is blah, 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 plus blah, and then you give it the last term. Because when you're given the last term, then you use your T sub n to calculate. Now don't forget the T sub n of a GP is that formula there. Please don't use the wrong T sub n. So when